All right, this is Unit 3, Lesson 4, Dividing Polynomials. So our essential question is, how can you divide polynomials? And at the end, you'll be able to divide polynomials. Okay, so in general, there are two ways to actually divide polynomials. You have long division, which is something that you're actually should be relatively used to, or you have synthetic division. So we'll actually go over how to do both. You'll be expected to know how to do both. On most of your tests, unless it specifically asks you to do long division or synthetic division, you should be able to choose whichever option you would like. So example 1, use long division to divide polynomials. So how can you use long division to divide p of x by d of x? Write the polynomial p of x in terms of the quotient and remainder. So I have p of x equals x cubed plus 5x squared plus 6x plus 9, and d of x equals x plus 3. So my solution, long division of polynomials, is similar to long division of numbers. I'm going to divide this by this. So I ask myself, how many times does x go into x cubed? Or x times what gives me x cubed? Well, x squared gives me x cubed. Okay. So then I multiply that x squared by the x plus 3. So x squared times x is x cubed, and x squared times 3 is 3x squared. And I subtract all of that, just like I would in normal division. X cubed minus x cubed is 0. 5x squared minus 3x squared gives me 2x squared, and then I bring down the next numbers, plus 6x plus 9. Okay. I then divide the leading terms again. So 2x squared is my leading term now. So x times what gives me 2x squared? Well, 2x gives me 2x squared. I then multiply the blue times x plus 3. Make sure to distribute the negative to all terms when subtracting. Okay. So 2x times x gives me 2x squared, and 2x times 3 gives me 6x. Then I subtract again. So 2x squared minus 2x squared is 0. 6x minus 6x is 0, and I'm left with 9. So the remainder is 9. When you divide the polynomials, you can express the relationship of the quotient and remainder to the dividend and divisor in two ways. So you can do the dividend divided by divisor equals the quotient plus the remainder over the divisor. This is the way I recommend, by the way. Okay. Or you can do the dividend equals the quotient times the divisor plus the remainder. Okay. So I get x squared plus 2x plus 9 over x plus 3. So in this case, you would do x squared plus 2x times x plus 3 plus 9. You get the same answer. How can you use long division to divide p of x by d of x? Write the polynomial p of x in terms of the quotient and the remainder. So I notice, let p of x equal 8x cubed plus 27. I'm missing a couple of x terms. I'm missing an x squared and I'm missing an x. So you're actually going to want to add those in when you divide. So the dividend is a cubic polynomial with no first or second degree term. So again, no x squared, no x. So I use 0 as the coefficient for the missing first and second degree terms. So 0x squared and 0x. Okay. So you need to make sure that you do that. This will be something that you have to do in synthetic division as well as long division. So get used to doing it. Okay. So again, I ask myself, 2x times what gives me 8x cubed? Well, 4x squared gives me 8x cubed when I multiply it. So 4x squared times 2x is 8x cubed. 4x squared times 3 gives me 12x squared. Okay, I then subtract. 8x cubed minus 8x cubed is 0. 0x squared minus 12x squared gives me negative 12x squared. And then I bring my other values down. I ask myself, 2x times what gives me negative 12x squared? Well, negative 6x gives me negative 12x squared. So minus 6x goes up top. I multiply. Negative 6x times 2x gives me negative 12x squared. And negative 6x times 3 gives me negative 18x. I then subtract. Negative 12x minus a negative 12x squared gives me 0. 0x minus a negative 18x gives me a positive 18x plus the 27 I bring down. I then ask myself, 2x times what gives me 18x? Well, 9 does. So 9 times 2x is 18x. 9 times 3 is 27. I then subtract. 18x minus 18x is 0. 27 minus 27 is 0. So the remainder is 0. This means the divisor is a factor of the dividend, okay? So when I do this, I get 4x squared minus 6x plus 9, or I could say 2x plus 3 times the quantity 4x squared minus 6x plus 9. I really recommend that you use this version and not this one. This will be helpful if you have to write out all the factors. I'll tell you that. All right, so now they want us to try it out. Use long division to divide the polynomials, then write the dividend in terms of the quotient and the remainder. Okay. So I have x cubed minus 6x squared plus 11x minus 6 divided by x squared minus 4x plus 3. All right, so when I'm dividing, I have x cubed minus 6x squared plus 11x minus 6, and I'm dividing by x squared minus 4x plus 3. So the first thing that I want to do, what times x squared gives me x cubed? Well, x times x squared gives me x cubed. Put my x over here. Then I multiply x times this. Well, x times x squared gives me x cubed. X times negative 4x gives me negative 4x squared. And x times 3 gives me 3x. Okay, I then subtract this. All right, so when I subtract, x cubed minus x cubed gives me 0. Negative 6x squared minus negative 4x gives me a negative 2x squared. And 11x minus 3x gives me 8x. Then I bring down the minus 6, okay? Now I ask myself, what times x squared gives me negative 2x squared? Well, negative 2 does. Okay, so I have negative 2, and then I multiply it by what's outside. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 4 gives me a positive 8x. Negative 2 times 3 gives me a negative 6. And I subtract. Negative 2x squared minus negative 2x squared is 0. 8x minus 8x is 0. Negative 6 minus a negative 6 is 0. So I have no remainder. So that means my answer is x minus 2. And then I can multiply that times my divisor. So I get x minus 2 times x squared minus 4x plus 3. All right, so number 1, I get x minus 2 times x 4x plus 3. Okay. For letter B, I have 16x to the 4th minus 85 divided by 4x squared plus 9. So if I look at this, x to the 4th, there's no x cubed, no x squared, no x. So I actually need to add those terms in when I go ahead and divide this. So when I do that, I get 16x to the 4th plus 0x cubed plus 0x squared plus 0x minus the 85. Okay, so nothing really actually changed. When I put those zeros in, it doesn't actually affect the dividend, okay, or the divisor. So I get 4x squared plus 9 on the outside, that's my divisor. So I have to ask myself, what times 4x squared gets me 16x to the 4th? Well, 4 times 4 gives me 16, and x squared gives me x squared times x squared gives me x to the 4th. So 4x squared. Okay, so now I have to multiply that 4x squared times everything outside. So 4x squared times 4x squared is 16x to the 4th, and 4x squared times 9 is going to give me 36x squared. Okay, I'm going to subtract this. okay? There's no x cubed, so I'm leaving it alone. So 16x to the fourth minus 16x to the fourth is 0. 0x cubed minus 0x cubed is 0. And 0x squared minus 36x squared is negative 36x squared. I then bring down my other terms. Okay. So now I have negative 36x squared plus 0x plus 8 minus 85. This is my new leading coefficient, negative 36. So 4 times 9 gives me 36, but I need it to be negative. So minus 9. Okay. Multiply that through. Negative 9 times 4 is negative 36x squared. Negative 9 times 9 is positive 81, or negative 81, sorry. Okay, and I have this term left over in the middle. I'm still leaving it there. It's still a placeholder, okay? Negative 36x squared minus negative 36x squared is 0. 0 minus 0 is 0. Negative 85 minus negative 81 gives me negative 4. Okay. Negative, negative make a positive, so I get negative 4. So negative 4 is left over. So when I do this, I get 4x squared minus 9 times 4x squared plus 9 minus 4. So 4x squared plus 9, 4x squared minus 9 minus 4. All right, next I'm going to use synthetic division to divide x minus a. Okay, so when I use synthetic division, it always has to be in the form x minus a. Okay, I can't have like 2x. I can't have any of that. It has to be 1x minus a. So what is 2x cubed minus 7x squared minus 4 divided by x minus 3? And I want to use synthetic division. So my solution is synthetic division is a method used to divide a polynomial by a linear expression in the form x minus a. Note that leading coefficient of the divisor is 1 and that a is the 0 of the divisor. So step 1, to change from long division format to synthetic division format, write only the 0 of the divisor and the coefficient of the dividend. Okay, so instead of x minus 3, I just write 3. And I write all my coefficients. So the 0 of the divisor is a, so x minus 3, 3. And then I have 2x cubed minus 7x squared plus 0x minus 4. Again, we had to add that 0x in because it wasn't in our original. So I have 2, negative 7, 0, negative 4. I bring down the first coefficient. 2 comes down. I multiply the 0 of the divisor by the first coefficient. 3 times 2 gives me 6. Then I add the result. So negative 7 plus 6 is negative 1. Then I repeat. 3 times negative 1 gives me negative 3. Plus 0 is negative 3. And then 3 times negative 3 gives me negative 9. Negative 4 plus negative 9 is negative 13. So use the numbers in the last row to write the quotient and the remainder. So the quotients or the coefficients of the quotient are 2, negative 1, negative 3, and negative 13. The last one is my remainder. Since the dividend is cubic and the divisor is linear, the quotient is quadratic. Okay, so basically so instead of x cubed, it now becomes x squared and you go from there. So I get 2x squared minus 1x minus 3 plus 13 over x minus 3. So this is now my divisor or my quotient. Okay, I can also write the dividend in the form of 2x squared minus x minus 3 times x minus 3 minus 13. All right, so let's try it out. Use synthetic division to divide 3x cubed minus 5x plus 10 by x minus 1. This is what I'm dividing, 3x cubed minus 5x plus 10 divided by x minus 1. So the first thing I want to do is I actually want to rewrite this so that it has all of my x factors. So I'm missing an x squared. So 3x cubed plus 0x squared minus 5x plus 10. Okay, so that's my a value, so that's what goes up front. Okay, so I have 1, okay, that's what I'm dividing by, 3, 0, negative 5, you want to make sure you include that minus sign, 10. Okay, now I bring the 3 down, I multiply by 1, that answer goes here, so I have 3. I add 0 plus 3 is 3 times 1 gives me 3. Negative 5 plus 3 is negative 2 times 1. Up here, negative 2 times 1 is negative 2. I add 10 plus negative 2 is 8. That's my remainder. Okay? So my solution, 3, 3, negative 2, 8. I started with x cubed, so that means I go down to an x squared. So I get 3x squared plus 3x minus 2 plus 8 over x minus 1. I can also write it as 3x squared plus 3x minus 2 plus 8 was multiplied by x minus 1. Okay. So x minus 1 times 3x squared plus 3x minus 2. So either of those answers is correct, 3x squared plus 3x minus 2 plus 8 over x minus 1, or x minus 1 times 3x squared minus 3x minus 2 plus 8. All right, example 3, conceptual understanding. Relate P of A to the remainder of P of X divided by X minus A. So how's the value of P of A related to the remainder of P of X divided by X minus A? So to explore this question, let P of X equals X cubed plus 10X squared plus 29X plus 24. Use synthetic division to divide P of X by X plus 5. Okay. To identify the value of A, I write the divisor X plus 5 in the form X minus A. Okay. So in order to do that, that means A has to be negative 5. Okay. Negative 5 represents the linear divisor, X minus A. The quotient is X squared plus 5X plus 4 with a remainder of 4. Okay. So again, bring down the 1, negative 5 times 1 is negative 5, 10 plus negative 5 is 5. Negative 5 times 5 is negative 25, 29 plus 20 plus a negative 25 is 4. Negative 5 times 4 is negative 20, 24 plus a negative 20 is 4. Okay. So P of X equals X squared plus 5X plus 4 times X plus 5 plus 4. Use this form to evaluate P at negative 5. So P at negative 5 is negative 5 squared plus 5 times negative 5 plus 4 times negative 5 plus 5 plus 4. So 25 minus 25 plus 4 times 0 plus 4. So 0 plus 4 equals 4. So negative 5 is the 0 of the divisor. So the product of the quotient and the divisor is 0. So P of negative 5 is the remainder 4 of P of X divided by X minus a negative 5. So in general, dividing P of X by X minus A results in a quotient, Q of X, and a remainder R. So P of X equals Q of X times X minus A plus R. So P of A equals Q of X A minus A plus R, where that's 0 plus R or the remainder. So evaluating P of X at A, the 0 of the divisor shows that P of A equals R. So for a polynomial P of X, the value of P of A is equal to the remainder of the division P of X divided by X minus A. Okay. So I want to use synthetic division to show that the remainder of f of x equals x cubed plus 8x squared plus 12x plus 5 divided by x plus 2 is equal to f of negative 2. So what I need to do is I actually need to do the division. So I have my division x cubed plus 8x squared plus 12x plus 5 divided by x plus 2. This is not in the form x minus a. Okay, I need to change that. Okay. Negative and a negative make a positive, so that's why it's the same thing. So -2 is what my a value is. Okay. I have 1, 8, 12, and 5 as my coefficients. Okay. I bring down my 1. -2 times 1 is -2. 8 plus -2 is 6. -2 times 6 is -12. 12 plus -12 is 0. 0 times -2 is 0. 5 plus 0 is 5. So 5 is my remainder. This is x squared plus 6x plus 5 over x plus 2. Okay. You can also write it as x plus 2 times x squared plus 6x plus 5. Okay. So when I do this, I want to go ahead and substitute -2 in for this and see what I get. So I get -2 plus 2, -2 squared plus 6 times -2 plus 5. This gives me 0, so anything I multiply is going to give me 0. So 0 plus 5 is 5. So when I divided everything, use synthetic division to divide and check to see that the remainder is 5, which we did. All right, so concept, remainder theorem and factor theorem. The remainder theorem states that if a polynomial p of x is divided by x minus a, the remainder is p of a. When x minus a is a factor of p of x, we can show that p of a equals 0. So p of x equals q of x times x minus a. Remember, we substitute an a for x, which gives us 0. Conversely, when p of a equals 0, we can show that x minus a is a factor. So p of x equals q of x times x minus a plus r. We're going to substitute p of a in for r. Okay. When I do that, that gives me 0. So that gives me q of x times x minus a. The factor theorem formalizes these 2 points. So the factor theorem states that the expression x minus a is a factor of a polynomial p of x if and only if p of a equals 0. All right, so example number 4, use the remainder theorem to evaluate polynomials. The population of tortoises on an island is modeled by the function p of x equals -x cubed plus 6x squared plus 12x plus 325, where x is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. So I use synthetic division to find p of a when a equals 8. Okay, so when I divide through, I get 293 as my estimated population. Okay, so the reason that a is 8 is 2015 to 2023 is a difference of 8. Okay, so that's why I'm dividing by 8. So I get 293, so the estimated population in 2023 is 293 tortoises. All right, so let's try it out. A technology company uses the function r of x equals -x cubed plus 12x squared plus 6x plus 80 to model expected annual revenue in thousands of dollars for a new product, where x is the number of years after the product is released. Use the remainder theorem to estimate the revenue in year 5. Okay, so 5 is going to be what I'm dividing by, so I'm going to go ahead and set up the equation. All right, so when I do this, I'm dividing by 5. -1 times 5 is -5. 12 plus -5 is 7. 7 times 5 is 35. 35 plus 6 is 41. And then 41 times 5 is 205. Plus 80 is 285. So 285,000. Okay, remember because they said that the original problem was in thousands, 285,000. All right, example 5, check whether x minus a is a factor of p of x. How can you use the remainder and factor theorems to determine whether the given binomial is a factor of p of x? If it is a factor, write the polynomial in factored form. So I have x to the fourth minus 8x cubed plus 16x squared minus 23x minus 6 with a binomial of x minus 6. So the binomial is x minus 6 is a factor of p of x if 6 is a 0 of p of x. So basically when I divide by 6, if I get 0 as a remainder, then it is a factor, okay? So I can use synthetic substitution, which is basically the synthetic division, or I can use direct substitution. I really recommend using synthetic substitution because it's going to be easier to factor, okay? In the long run, if you move on to pre-calculus, you'll need this. This is actually something you'll see again, and you'll actually be asked to factor it out even further. So I recommend using synthetic substitution and getting to know it really well. You can use direct substitution. It's not wrong. It's not an incorrect method. You'll still get the same answer. Okay. So either way, I do get 0 because p of 6 equals 0, you can use the factor theorem to conclude that x minus 6 is a factor of p of x. So p of x equals x cubed minus 2x squared plus 4x plus 1 times x minus 6. How can I use the remainder and factor theorems to determine whether the given binomial is a factor of p of x? If it is a factor, write the polynomial in factored form. So I have x to the fifth minus 5x cubed plus 9x squared minus x plus 3, and I'm dividing by x plus 3. That's my binomial. So negative 3 is what goes in front, and that's what I put in for my substitution. I get negative 21 in both cases. So that means that negative 3 is not a 0 of p of x, so you cannot use the factor theorem to conclude that x plus 3 is not a factor of p of x. All right, so let's try it. Use the remainder and factor theorems to determine whether the given binomial is a factor of p of x. So a p of x equals x cubed minus 10x squared plus 28x minus 16 with a binomial of x minus 4. Okay, so I went ahead and set this up. So I have 4 that I'm going to bring down, or no, sorry, 1 that I'm going to bring down. 1 times 4 is 4. Negative 10 plus 4 is negative 6. So negative 6 times 4 is negative 24. 28 plus a negative 24 is 4, and then 4 times 4 is 16, so I get 0. Okay, so this is a factor. Okay, so it is a factor. All right, then I have b p of x equals 2x to the fourth plus 9x cubed minus 2x squared plus 6x minus 40 with a binomial of x plus 5. So when I do this, I'm going to, x plus 5 has to be negative 5 up front. I have 2, 9, negative 2, 6, negative 40. 2 comes down. 2 times negative 5 is negative 10. 9 plus negative 10 is negative 1. Negative 5 times negative 1 is 5. Negative 2 plus 5 is 3. Negative 5 times 3 is negative 15. 6 plus negative 15 is negative 8. Nine is negative 9. Negative 9 times negative 5 is positive 45. So I have a remainder of 5. Okay, so that's not a factor. Okay, so because it's not because the remainder is not 0, x plus 5 is not a factor. Okay. So concept summary, dividing polynomials. When I divide, you can use long division or synthetic division. Either way works. Unless it specifically asks you to use a specific method, it's completely up to you. You can write your answer either way, multiplying what you got times your dividend plus your remainder, or you can write it as your quotient plus your remainder over your dividend. Okay. And that is the end of Unit 3, Lesson 4.